Well, like a kid with a new toy at Christmas, I could not help but get these plates wet. So here we have the first test tonight of the new zero cell, experimental zero cell in potassium hydroxide. Maybe I can get you, here's a little container of the potassium hydroxide flakes. Okay. These are not thin flakes. I want to say they're probably about 20 thousandths of an inch thick. They were thicker than I expected. And I want to give you some idea of the scale that we're looking at here. This is a quarter, 25-cent piece that I'm holding up to this, so you get some idea of the overall dimensions of this. Obviously, we're in my little plastic container, salvaged from Betty Crocker frosting, pre-mixed, and they made very nice cupcakes. Thank you. The level of the solution is just to the top of the edge of the plates, and what I want to show you tonight is a couple of things. First thing I want to say is that the black windshield urethane adhesive that I used to assemble this cell has dielectric properties that are off the map. When I attempted to measure what the actual capacitance was of this total cell for my experiments upcoming with pulse width modulation and trying to create a resonant tank circuit out of these plates, or having these plates part of the resonant tank circuit, you need to be able to calculate what the capacitance value is of the plates submerged in your water. Well, the actual value that I showed versus what I predicted was 238,000 times greater than what the calculations predicted. And when I went back and checked a couple of plates around the black urethane adhesive, which had already been cured, sure enough, it is a electrolyte unto itself. So the black urethane adhesive that runs along both sides of the plate column that secures the plates together has a zero gap between the plates. Apparently the black pigment is conductive, although you cannot measure the resistance through the urethane adhesive, and it makes the overall capacitance value of the cell completely unpredictable. That was unfortunate. Anyway, the other thing that I had observed with my tall zero cell in the car, and I was a little concerned about it, was when I energized the cell, what I observed was a great amount of production from the center negative plate and less from the intermediate neutral plates, and a little bit more from the positive plates, but not as much as the negative. I had settled on just under 2 volts per plate cavity. So for every plate, there's 2 volts dropped in between, with 13.8 volts going in and 7 cavities altogether, divided among the 13.8 volts. I'm going to show you what 13.8 volts looks like in my new cell. All right, here we go. 1, 2, 3. And what did you see? That's actually 14 volts, 1 1/4 amps. And you can see very clearly that with that amount of voltage dropping across each cell, that I am just barely at the point where the plates are beginning to release gas. Okay. Next, I'm going to bring it up to 16 volts. Okay. That's 16.3 volts, 2.86 amps. I'm going to turn it off again, and I'm going to plug it in very quickly, and you'll see the difference. right away you can see that there's enough current flowing through the cell and enough voltage across each cell to much more evenly distribute the charge that's being shared among the cells, and suddenly all of the plates are in the game. Go back to 14 volts. I'll unplug it. Now we're not looking so much at the total gas production as we are the distribution of the gas production across the plate stack. So it's pretty clear that in between the energized electrodes, as you get further and further away from an energized electrode, the voltage drop across each plate gets less and less until you start approaching the next electrode. It's a non-linear gradient going between the two energized electrodes on either side of the negative plate. The only way I can think perhaps to compensate for that might be to create a non-linear gradient in the spacing of the plates as you create the stack. As this stack is created, it is exactly 45 thousandths of an inch between every single plate. It's a linear spacing, but the gradient of the current passing through is non-linear. You can equalize the charge more readily across the plate stack if you get past the point where the current begins to increase exponentially. And if I go to my calculator here, I still have it up on the computer. 16 divided by 7 is 2.28 volts per cell. So just going up a little bit more than 1/4 of a volt per cell evenly distributed the current passing through the stack of plates and caused every plate to get into the game. I've got to believe that this is considerably more efficient to do it this way. Alright, now what you see in the picture is a couple of shims that I've inserted between the positive electrode and the next adjacent neutral plate. So what I've essentially done is I've shifted the energized electrode in one plate, and now I only have 5 neutral plates instead of 6, and 6 plate cavities in between the electrodes. I'm going to bring it back down to 12 volt or 14 volts, 13.8. And with 13.8 to 14 volts, we have approximately 2.3 volts per cell. And when I plug it in and energize it, you can see that distribution is very even. Conclusion: going forward, my cells will not have 6 neutral plates. They will have 5. There will be 6 cavities in between, and my voltage per cell, target voltage, is going to be 2.3 to 2.5 volts is what I'm shooting for. And if I really start to crank it up, this is 20 volts at about, and this is 19 volts at 6 amps, and you can see that's some pretty wild production right there. And I'm going to turn it off and I'll plug it in quickly again. And it just bursts. That's about 120 watts, I'm going to say, of power going in. And very shortly I will have gas production numbers for this cell at 120 watts. Please remember, this is also the new plate material. This is 316L stainless steel in distilled water with potassium hydroxide as my electrolyte, and a very tiny bit at that. If a 1/4 of a teaspoon, that's a lot. We'll be back later. Hopefully we'll have some gas production numbers for you.